Hello, this video is on dividing with fractions. We're going to be specifically looking at dividing whole numbers by unit fractions and dividing unit fractions by whole numbers. Going into this video, I want to explain one thing. When I think of dividing fractions by whole numbers or whole numbers by fractions, what I'm really trying to ask myself, specifically with the dividing the whole number by a fraction, is how many of the divisors, or how many divisors are there in the dividend? So in this case, what I'm asking in this problem, 6 divided by 1/2, is how many halves are there in 6 wholes? So what I'm going to do is go ahead and draw 6 wholes, and I'm going to cheat here so that all of my wholes are relatively similar. I'm going to use the cloning tool on my laptop. And I'll organize these so that we can actually see what we have. So by using that cloning tool, I ended up with 6 wholes, and each hole is divided into halves. Now what I'm going to do is go through and just count those halves. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the answer to 6 divided by 1/2 equals 12. Now, most people learn the rule of same inverse reciprocal, or the more friendly way to remember that is keep, change, flip. So what I am going to do is just work this out mathematically using the algorithm so that you can see how the algorithm connects to the model. So if I follow those rules, same inverse reciprocal, what I'm going to do is leave the 6 alone, and I'm going to change the division symbol, or I'm going to change the operation to multiplication. So it's going to be 6 times 2 over 1. Now, just for consistency here, I'm going to write a 1 up underneath my 6. And then once I do the keep, the change, and the flip process, I'm going to just simply multiply as if I were multiplying, just normally multiplying fractions. So I'm going to multiply the numerator. So in this case, it'll be 6 times 2, which is 12. And then I'll multiply the denominator. So I have 1 times 1, which is 1. And then I can just write that as a whole number, which is 12. So again, for the modeling part, I drew 6 holes. I divided each of the holes in half, and then you're really just counting the number of halves that you have in each hole, which in this case is going to be 12. This next problem is a word problem. I like to use word problems to help students paint a picture of exactly what they're being asked to do. So this one says, Judy has 8 quarts of lemonade. Judy wants to serve the lemonade in 1/4 quart servings. How many servings does Judy have? So I have 8 quarts, and what I'm trying to figure out is how many times I can take 1/4 out of 8. So I'm going to draw 8 holes, and then I'm going to divide each hole into fourths. And again, on this one, I'm going to use my cloning tool so that I do not have to do this 8 times. Okay, let's just neatly arrange these on the screen. So now I have my 8 holes. Each hole is divided into 4 parts. Now I'm just going to go through and count to see exactly how many fourths I have. And instead of writing 1/4 in here, I'm just going to draw a dot to show that I've already counted a specific fourth. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, and 32. So those 8 fourths divided into 1/4 servings gives you a total of 32 servings. Now, I'm going to apply the same inverse reciprocal or keep, change, flip method. I am going to keep the 8, take the inverse of division, which is multiplication, take the reciprocal of 1/4, which is just 4/1. I'm going to write my 1 up under 8 to remain consistent here, showing my denominators. And then I'm just going to multiply across numerator times numerator, which is 32, and then denominator times denominator, which is 1. And then I'll just clean that up to make it solid 32. So Judy had 32, or Judy has 32 cups, or 32 servings of lemonade. All right, this next example is modeling dividing a fraction by a whole number. So I intentionally, for the first problem and this particular problem here, use the same numbers, but you'll notice the 1/2 is now the dividend and the 6 is now our divisor. So with this particular problem, I like to think of it as being, as you're asking the question, if 1/2 is split into 6 equal parts, what fraction of the whole would each part represent? So what I'm going to do is draw a hole, and then with this hole, I'm going to split it in half, and this bottom part, I'm just going to shade in because I don't need it to solve this problem. I really just need the top because it says that I'm taking, I'm trying and dividing 1/2 by 6. So I just want to be able to show 1/2. I'm going to leave the 1/2 I'm going to work with blank. I'm going to change the color up here so it'll be easier for you to see. So again, the question should be if 1/2, or you can think about the question as if 1/2 is split into six equal parts, what fraction of the whole would each part represent? When I'm dividing this into the 6 parts, I'm going to show the whole model being divided into 6 parts because the question really asks us what fraction would each part, each of those 6 parts, represent of the whole model itself. So now you'll notice that my whole model is divided into 6 parts. I split it originally into 2/2, so that means that I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 parts in the whole. But I'm only going to focus in half, and I'm trying to figure out the value of each half. So if the whole thing is 12, each one of these smaller rectangles will equal 1/12. So if there's 6/12 in 1/2, that means there are going to be 6/12 in the other half, which gives you 12/12 or 1/2. But the question is really asking us again, I'll say, is what fraction of the whole would each part represent? And in that case, it would be I'm going to apply the same inverse reciprocal or keep change flip method. The 1/2 will remain the same. Take the inverse of division, and it becomes multiplication. Remember, a whole number has a denominator of 1, or can be written with a denominator of 1. So what I'm going to do is take the reciprocal of 6 over 1 and make it 1/6. And we're just going to multiply numerators. 1 times 1 is 1, and then 2 times 6 is 12. So therefore, 1/2 divided by 6 equals 1/12. All right, just like with the dividing a whole number by a unit fraction, I gave a word problem. I also want to give a word problem so that you can know how to apply dividing a unit fraction by a whole number. It says John had 1/4 of his birthday cake left over. He wanted to split the cake between himself and 4 friends. What fraction of the whole cake will each person get? And the verb tense there doesn't match up as I would like, so I'm going to change this to John has. One-fourth of his birthday cake, and he wants to split the cake between himself and 4 friends. What fraction of the cake will each person get? So, I'm going to draw a model to represent John's birthday cake. And I'm going to split that birthday cake into 4 parts so that I can show the 1/4 that he actually still has. So 3 of those fourths have been eaten. I'm going to draw in or shade in just one of them. Actually, I'll shade in 3 of the 4 and leave 1/4 blank. Alright, I'm not going to worry about filling those in completely, but let's go back and look at the problem. It says he has 1/4 of his birthday cake, and he wants to split the cake between himself and 4 friends. So that part gives you a total of 5 people. So what we need to do is divide this birthday cake up, or the remaining birthday cake up into 5 parts. Just like the last one, I want to show the whole cake being divided into 5 parts because the question asks us, it says what fraction of the whole cake will each person get. Although they only have these 5 parts right here, we still need to reference our answer back to the whole. Now, what we need to do is pay attention to how many parts our whole is divided into. We have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 parts. So each one will represent 1/20. And I need to go back and rewrite my expression for this problem, which is 1/4 divided by 5, which I'm going to use the same inverse reciprocal methods, and that is going to be 1/4 times 1/5, and then I multiply the numerators. 1 times 1, which is 1, 4 times 5, which is 20. So each person will get 1/20th of the whole cake. All right. Thank you for checking out this video. I hope it helps. If you have any questions or comments, feel free to email me at deloacheducation@gmail.com or